This is my first run at Algebra 2 video. Algebra 2, yay. We're starting on a chapter on radicals and rational exponents. And so before we launch into that, I wanted to remind you of some properties of exponents that you in theory already know. Like, for example, anything raised to the 0 power is equal to 1, except for when a is 0. So this is true as long as a isn't 0. Also, it's important to remember that a to the negative 1 is equal to, negative n is equal to 1 over n. A to the negative n, a to the negative n is equal to 1 over a to the n. So the negative exponent just means we're dealing with the reciprocal rather than the thing we're talking about. Likewise, there's some basic properties. For example, you know that when you do a to the m times a to the n, a shortcut is that you could just add the exponents, a to the m plus n. And that's true because, remember, the exponents are just counting the number of times we're multiplying by the base, in this case a. So if this says I'm multiplying by a m times, this says I'm multiplying by a n times, so that means the total amount of times I'm multiplying by a would be m plus n. This, of course, only works if the bases are the same. And likewise, if we have a to the m divided by a to the n, that could be a shortcut for that, would just be to subtract the exponents. And two more. Remember that ab to the n is really, this is just raising both a and b to the n power and multiply them. So you could rewrite this as a to the n and b to the n. And then finally, last but not least, a to the m raised to the n, that's equal to a to the m times n. So when we're raising a power to a power, you can just multiply the exponents. So those are some basic properties that you should already know. So let's put them to work. So for example, if I have 5a to the 3rd power times negative 3a to the negative 4 power. So of course, it doesn't change all the other things that we already know. In this case, we're multiplying. So we're multiplying by a whole bunch of things. We're multiplying 5 times a times itself 3 times, and then times negative 3, and then times the reciprocal of a 4 times. So you could do this, and because multiplication is commutative, that means I can multiply in any order I want. I could multiply 5 times negative 3 first. That would give me negative 15. And then I'd have an a to the 3rd and an a to the negative 4. But of course, since a to the 3rd and a to the negative 4 have the same base, I can simplify that. And so we could leave it the way it is and multiply it. And since they have the same base and you're multiplying, you just add the exponents. So that'd be 3 plus negative 4, which end up being a to the negative 1. Or if you write this as negative 15 a to the 3rd, change a to the negative 4 to 1 over a to the 4th, then that, of course, would be negative 15, oops-a-daisy, negative 15 times a to the 3rd over a to the 4th. And when I'm dividing, I just subtract. So that would be negative 15 a to the negative 1. Get the same answer. And of course, you could write this as negative 15 over a, because again, negative a to the negative 1 is the same thing as 1 over a. So there's one example. Let me do another one. What if we have like negative 4 x to the negative 3 and y to the 5th, all raised to the 2nd power. Okay, so here's one. We can use this rule up here. When you have an exponent on the outside, you can just multiply, or you can apply it to everything inside the parentheses. So this would be negative 4 squared times x to the negative 3 squared times y to the 5th squared. And of course, negative 4 squared would be negative 4 times negative 4, which would just be 16. X to the negative, that's supposed to be a negative there, I didn't make that very big. X to the negative 3 squared would be x to the negative 3 times x to the negative 3, which would be x to the negative 6. And y to the 5th squared would be y to the 5th times y to the 5th, which would be y to the 10th. And you could leave it like that, or you could write it as 16y to the 10th over x to the 6th. I think in the directions in the assignment you're going to do, it says simplify each expression, use only positive exponents. So that's, you'd have to write it like this then, if they say to use only positive exponents. So there's a couple examples. Again, this is in theory kind of review, so you should be able to whip through this assignment. So this, you should be able to handle the assignment on page 360. And then the other thing I wanted to remind you of just what a root was. So if I have, remember that if I just have like this, that would just be square root. But if I put a little number in the pocket, like 3, that means cube root or fourth root. And remember, a root is something that's multiplied by itself to get the thing inside the radical. So for example, if I have the square root of 25, that means I'm looking for something that I can multiply by itself to get 25. And since this is an even root, we know that it would be 5 or negative 5, because 5 times 5 is 25, and negative 5 times negative 5 is also 25. Now in the cube root, of course, let's say something like, we'll say we're trying to take the cube root of 8. The cube root of 8 would mean what times itself 3 times would equal 8. So we're like looking for some number that we can raise to the third power and get 8. And in this case, there isn't a positive or negative, because if it was negative, a negative times a negative times a negative would produce a negative number. So because the cube root is positive, that means my answer is also going to be positive. And in this case, the answer would be 2. 2, because 2 to the third power is equal to 8. And likewise, if we give an example of 14, whoops, sorry, my battery just died, and so I had to plug it in and fire it up again. So here we go, picking up where we left off. So I was about to do a fourth root. So like, for example, if I put 16 in there, I'm asking what's the fourth root of 16, which means what times itself 4 times would equal 16. And again, because this is an even root, that was square root, this is fourth root, there's going to be 2 answers, because 2 times 2 times 2 times 2 is equal to 16, but also negative 2 times itself 4 times is equal to 16. Or to write that more clearly, that is equal to 16. That's why 2 is the answer for that. Now, if we have some variables involved, let's say we have like the square root of 9x to the 4th. Well, again, we can apply the square root to both of these problems individually, so that really kind of goes back to this rule here, right? We can just apply the outside power. In this case, it's an outside root. So I can take the square root of 9, which of course would be 3 or negative 3. And then I can take the square root of x to the 4th. So I'm asking myself, what times itself equals x to the 4th? Well, that would be x squared. So I can put an x squared there and also an x squared there. So you can see essentially that well, maybe it's not obvious after one example, but you, to find the square root of a variable raised to a power, you're just dividing the power by 2. And you can see that if we go further into this, let's say we're looking for the cube root of x to the 6th and y to the 9th. Well, once again, I'm saying x to the 6th, what times itself 3 times equals x to the 6th? That would be x squared. And what times itself 3 times equals y to the 9th? That would be y cubed. And so, so that's kind of a nifty little trick. You can see that you just divide the exponents by the number in the pocket. But again, it works because x squared to the third power is equal to x to the sixth. And remember, we multiply those exponents when we're raising a power to power, and that's why we divide by 3 to get that. Okay, so that should get you going on the first two assignments. There's assignment on page 364 and the assignment on page 360. And like I said, they're kind of review. I think you guys already knew this. Oh, let me do one more example. Let's say I have the square root of 0.25. That one's sometimes kind of tricky. So we know that 5 times 5 equals 25, right? But clearly but this is a 0.25. So if I did, for example, 0.5 times 0.5, that's going to be 25, of course. And remember, we count, since there's 1, 2 digits behind the decimal, then that would be 0.25. So that would work. So let's be careful, though. What if I had 0.0025? We wouldn't just put 2 zeros in front of it, because notice if I have 0.05 times 0.05, that would be equal to 25 again. And this time we need 1, 2, 3, 4 digits behind the decimal. So I'd put a 0 there, a 0 there, point. And so in this case, we notice that 0.05 works, not 0.005. Okay, so my answer would be 0.05, or of course negative 0.05, so you could put a plus or minus 0.05 there. All right, so that should wrap it up. Hopefully that'll help you get going on the first two assignments, and we'll see each other on Thursday.